What is electromagnetic induction? Faraday's laws and Lenz's law. Electromagnetic induction. Electromagnetic induction is a phenomenon whereby an electromotive force EMF is induced in a coil whenever there is a change in the magnetic flux linked with the coil. This can be demonstrated through an experiment involving an insulated copper wire wrapped around a cylinder to form a solenoid. When a magnet is brought close to the solenoid and moved towards or away from it, a current flows in the solenoid. The direction of the induced EMF can be determined using Fleming's right-hand rule. And Lenz's law states that the induced EMF always opposes the change that produces it. Experiment. Find an insulated copper wire and wrap it around a cylinder to form a coil in the shape of a solenoid. Connect the two ends of the coil to a galvanometer and place a magnet close to it. The galvanometer reading is 0 when the magnet is stationary. When the north pole of the magnet is moved towards the solenoid, the galvanometer shows a deflection towards the right. When the motion of the magnet stops, the galvanometer shows 0 reading, proving that current flows in the solenoid as long as the magnet keeps moving. If the magnet is moved away from the solenoid, the current flows in the opposite direction, and the galvanometer deflects towards the left. The deflection of the galvanometer can be increased by using a strong magnet or increasing the motion of the magnet. Increasing the area or the number of turns also creates a strong current in the coil. Faraday's laws of electromagnetic induction. Based on his experiment, Faraday formulated 2 laws of electromagnetic induction. Whenever there is a change in the magnetic flux linked with a coil, an electromotive force is induced. The magnitude of the induced EMF is directly proportional to the rate of change of the magnetic flux linked with the coil. Fleming's right-hand rule. Fleming's right-hand rule can be used to determine the direction of motion or the direction of induced current. The thumb, forefinger, and middle finger of the right hand are stretched perpendicular to each other, and the thumb represents the direction of movement of the conductor. The forefinger represents the direction of the magnetic field, and the middle finger represents the direction of the induced current. Lenz's law. Lenz's law states that the direction of the induced EMF is such that it always tends to oppose the cause which produces it. It obeys Newton's third law of motion, which states that to every action there is always an equal and opposite reaction. It also obeys the law of conservation of energy, which states that energy can neither be created nor destroyed. Therefore, the sum of all